All right, we're recording. So welcome everyone to the final senior seminar of the 2021 series. We're going to be hearing from Lindsay Lucas today, and her advisor, Allison Fleshman, is going to be doing her introduction.
Yay! Cool. So I have the pleasure of introducing Lindsay. Lindsay started working with me many years ago, and just to share the path that led to this talk. I do work with basically the chemistry of art, which is exciting. There's some former chemistry of art students in the audience as well. Lindsay's interest in forensic science and forensic chemistry kind of got our paths to cross. I had this great project. And she's going to talk a little bit about some of the technology and science behind it in her talk. But we did all this work, and then we were about to go to collect some data for these manuscripts, and basically, like, we ended up not being able to. And then I think I went on maternity leave. And so it just kind of ended. And then she did all this work on a different project that I was like, okay, now we can do this other work with what's called my Raman spectrometer. So she gets all prepared, she does all this literature research, and then the instrument dies. And so it was like time and time again, we just kept running into these barriers. But I think Lindsay truly embodies this idea of perseverance with a student. She's taught me a lot about, you know what, things are tough right now, but I'm just going to keep going, because she's faced some obstacles and she's confronted them head on, and it's shown a level of grace, and that she's maintained her curiosity in the sciences, and it's just kept driving her forward. And so that's been inspiring to see. And she's also taken some pretty hard classes with me. She's in my quantum chemistry class right now. And so again, she's just confronting those challenges head on. So it's been fantastic to see her develop as a scientist. And then I look forward to seeing her follow her path in forensic science, which I believe it will be graduate school, not this year, but next year, applying to graduate school. So very smart and taking a gap year, as all of you should, or not, depending, whatever fits best. But anyway, so it's been an absolute pleasure to see Lindsay grow, and I'm excited for her to share the work that she has done on illuminated manuscripts. Take it away, Lindsay.
Right. Can everybody see this okay? Great. All right. Well, thank you, Allison, for that lovely introduction. So today I'm going to be talking about methods for analyzing parchment and dyes in illuminated manuscripts. So first of all, what exactly is a manuscript? I'm sure you've all heard the word manuscript before, but what does it mean? So if you break manuscript down to its Latin roots, it literally means handwritten. So manuscripts are handwritten documents. All of the stuff that I'm looking at here are handwritten on parchment, and illuminated manuscripts have illuminations. So on the right is an example of an illumination. Illuminations are basically just fancy artwork that's painted in these documents. And then on the left, I have an example of some sheet music that was used in a church. A lot of these manuscript examples are used in religious contexts. So there's a lot of things used in church and a lot of pocket Bibles and stuff like that. So why do we care about manuscript analysis? What's the point of doing this? So one big thing is art conservation. So a lot of these manuscripts are very old, and they need to be cared for properly. And a lot of these manuscripts are, well, all of them are unique because they're all handwritten. This was before printing presses were available. So all of these like books and stuff are all handwritten. And if one gets destroyed, then it's gone and you don't have anything else exactly like that. And this conservation is very important for historical reasons too, because a lot of these have historical documents, historical connotations, a lot of things you can learn from them. So it's important to know how to care for them properly so they don't get damaged and destroyed. So one of the things I'll be looking at today is color in manuscripts. So here is two examples of different manuscripts. On the left, very plain, only a tiny bit of color. On the right, there's obviously a lot more color. The text looks a little fancier. So left, just the color in the top, there's only red. And on the left, you have a lot more color. You have the red in the text, and you also have this illumination. So what this can tell us is about basically like the wealth of the owner, like who might have owned it. Illuminations were, well, pigments were expensive. It wasn't easy to always get illuminations and things like this in your manuscripts. So the more color and the fancier the illumination means the more wealthier the owner was. And like for context, with on the left of a more common owner, pocket Bibles and things like that, often families who didn't have as much money, they would just have like one very plain pocket Bible that they would share throughout the entire family. So that really, the color can really tell us a lot about that. And then the other thing I'm going to be talking about is parchment. So what can the parchment tell us? So if you look on the right, I have a map from a study where they took a ton of manuscripts where they knew what animal the parchment was made out of. And they kind of determined the most common locations, like which countries these animals were mostly used in and which time periods. So for example, if we have a manuscript that we know is made of sheepskin, what can this data tell us? Well, we can probably assume that it's from the UK, because based on this data, that is the area where sheepskin was most likely used. Now, this doesn't necessarily help us narrow down the time too much, but there are other things when you get into manuscript analysis that could probably help you narrow the time down as well. So I've been talking about parchment, but what exactly is it? So parchment is, you can think of it like how we use paper, or we use like wood to make paper nowadays. It's like they used animal skin for their paper. So on the left, this is one of the techniques used to make parchment. It's basically taking animal skin and drying it out until it's usable. And on the right, so all parchment has two sides to it. There's the follicle side and the flesh side. So the follicle side, it's not very easy to see in this picture. It's a lot easier to see in person, but basically the follicle side has all of these little bumps and ridges, and that is where all of the hairs were on the animal coming out of their skin. And then the flesh side is a lot smoother. So one important thing to know about parchment is the difference between modern parchment and more historical older parchment. You have to think about how a lot of these manuscripts that are being studied are from between like the 12th and the 14th century. So they're very old. And as you can see here, so on the top is some modern sheepskin, and on the bottom is some older sheepskin from a historical document. And just from the coloration alone, you can tell that there are a lot of differences. And this can come into play a lot with experimentation and analysis. So when trying out new techniques, you don't always want to test it out on one of the historical manuscripts in case you damage it or something goes wrong. So there have been techniques developed to take modern parchment and to age it so it can replicate kind of how the historical parchment acts, so that you can test techniques and things on the aged parchment rather than having to use an actual document that you don't want to risk damaging in any way. So what exactly in the parchment are we looking at to figure out what animal it might be made out of? So collagen is one of the most abundant proteins in your body. It's very important to structure in your body. So There's a lot of collagen in your skin, and it helps the structure of your connective tissues and things like that. And the reason it's so strong is because it's made of these collagen fibrils, which when they're like stacked together, they form a very strong structure. And when you break it down, they break down into collagen microfibrils, and then those break down into the collagen molecule, which is a three-stranded alpha helices. And then when you break down one of the alpha helices, you get the amino acids. So the amino acids are specifically what we're looking at in the collagen of this parchment. So the amino acid sequence differs slightly for all of these animals that the parchment is made out of. So those slight differences in the sequence is what can tell us which animal we're looking at. So before I get into the methods, destructive and non-destructive analysis is very important to think about. So because of the history of a lot of these manuscripts and the fact that they're unique, and there's only one of a lot of them, we really want to stick to non-destructive analysis if possible. This has not always been the case in the past because we haven't always had non-destructive techniques. So a lot of older techniques are destructive in some form, but that's something that try to stay away from if possible. And another important thing is destructive versus invasive. If you ever look into this topic, a lot of authors use these words kind of interchangeably, but it is important to know the distinction. So destructive, as you destroy something, it can't be used again. So if you take a sample of a parchment, if you cut a little piece of parchment out, you analyze it, you would no longer be able to use that piece again, and you would have to take another piece to do the same analysis. Invasive is not destructive, it just alters something slightly. So it's still usable, but it does alter it a little bit. So the goal really is the ultimate method would be both non-destructive and non-invasive to protect these manuscripts. So to talk about some non-invasive parchment sampling. So here we have a piece of parchment, and what we would do with this is we would find a nice little area of the parchment that is unstained. This is considered non-invasive as long as you stay away from any of the text or illuminations or anything else on the parchment that's considered very important. So what we do here is we take the eraser and you just literally erase a little tiny piece of this parchment. And what that does is it takes off this little layer, a little top layer on the parchment, and that gives you something that is called Urdu. And that Urdu consists of pieces of the eraser and also that little layer that you took off of the parchment. That includes some collagen, which is what we want to look at. So we take this Urdu and it goes through an incubation and centrifugation process. And really what this whole process is doing is it's trying to extract the collagen so that further analysis, it's easier for us to look at the collagen to figure out the exact amino acid sequence that we're looking for. So one of the ways that we can analyze this collagen is using MALDI-TOF-MS. So MALDI-TOF-MS stands for Matrix Assisted Laser Desorption Time of Flight Mass Spectrometry. So this is kind of a lot. I'm going to break it down into smaller pieces so it's easier to understand. So the first step, you get the sample and you put it onto a crystallized matrix. A laser will shoot down into the sample, and that both ionizes and vaporizes the sample. And then there is high voltage and electric field that causes the ionized sample to go upwards into the next step. So this next step is the time of flight step, or the field free drift. And this is a very important step because this is where your sample separates into the different things that you want to look at. So heavier things with more mass, take longer to drift upwards through this field. And lighter things with less mass will go much faster. So for example, here, the pink has a higher mass than the blue sample in this situation. And then that will go up into the detector. So you can use many detectors. There are a lot of different detectors for MALDI-TOF, but in this case, because we're looking at mass, we want to use the mass spectrometer. So what does the mass spectrometer spectra look like? So this is some example spectra of a sheep parchment and goat parchment collagen. And just from this, it really doesn't look like there's that much of a difference, right? The goat is just slightly shifted to the right. There's a little higher mass. But what we're going to look at is we're going to break down the sheep parchment a little bit to see what you're really looking into. So this is a very zoomed in version of that sheep peak. And all of these peaks are very important to the collagen and amino acids we're looking at. So if you see all of these Ys that are labeled, every single one of these Ys represents a different amino acid. And both the peak size and the positioning of the peaks can tell us which amino acid it is and the order that the amino acids are in. So by taking this information from the spectra, we can tell the exact amino acid sequence of the collagen, and that exact sequence can tell us if, say, it's a sheep or a goat or a cow, which skin exactly it is. So now to go into some color. So dyes and pigments. On the left, I have some examples of what some dyes on parchment looks like. And on the right, I have another illumination. And illuminations like this on the right, they're very rare. They're not usually this fancy, but when they are this fancy, they're interesting to look at because you have a lot of different colors to work with. So there's some differences between dyes and pigments. So dyes are a lot more soluble. Pigments are not as soluble. Dyes more chemically bond to parchment, while pigments more physically bond to parchment. And dyes and pigments, there is some differences in the light scattering. So some of the techniques I'm going to talk about will more be about pigments because of the way the light scatters with them. So here I have, we're going to look at some purple. So this is a manuscript that has been dyed with purple dye. And two of the purple dyes or pigments that are important here are Tyrian purple, which is also known as royal purple, and Orchil, which is made from orison. So the royal purple was very, very expensive and hard to come by. So if any manuscript had royal purple in it, you pretty much knew that whoever owned that manuscript was very, very wealthy. And purple is not a very common color in manuscripts, but orison was much easier to come by. So when analyzing a manuscript, if you find orison instead, then there's not necessarily an extremely wealthy owner that had it. So one of the ways we can look at color and pigments is with FT Raman. So how FT Raman works basically is light will shoot into your sample, and what we want to look at is how the light exits the sample. So 99% of the light will exit the sample in the same path. But what really matters is the 1% that of light that exits in a different way. So we want to look at the change in how that light comes out. And that's the light scattering that we're going to focus on, because different pigments will scatter light slightly different in that 1%. And that is how you can tell the difference between pigments. So here is an example of vermilion. which is a red color. And on the top spectra, that is known vermilion spectra. So you can see the 2 peaks on the right are the most important. So if you have those peaks, you know that you have vermilion. And on the bottom is an unknown from a manuscript. And as we can tell from this, it looks like it is in fact vermilion. And I wanted to show the spectra because I wanted to explain a little about the peaks on the left. So you see there's 2 peaks on the left of the experimental sample. And it's important to think about with these manuscripts because of their age and just how they were made. It's very common for there to be contamination in these pigments. So when analyzing these, it's never to be expected that they will be completely pure. So there's always usually going to be some peaks of other things when you're analyzing an unknown color. So another way to use Raman to analyze pigments is with SIRS, which is Surface Enhanced Raman Spectroscopy. So SIRS is an invasive method. And how SIRS works is you take a little bit of the sample. So you take a tiny bit of pigment off of your manuscript and you make a metal ion complex. There's usually some gold and silver involved. And the way the complex is formed is there are some divots in it that the light from the Raman comes down into, and that basically enhances the signal so that the data you get off of it is you get a lot more data off of it basically if you use the same amount of sample compared to the FT Raman. So here's an example of what SIRS looks like. And this is Orison. This is the purple color that I was talking about earlier. And if we compare this to FT Raman, as you can tell, this method is a lot more sensitive. You get a lot more information using the same amount of sample. So this can be preferable over FT Raman for that reason. Another method to look at pigments is called scissors. This is subtracted shift-in Raman spectroscopy. So how scissors works is, unlike SIRS, you don't actually do anything to the sample. Scissors just takes a FT Raman spectra and you basically mathematically manipulate the spectra. So scissors takes slightly shifted spectra and part of the process is subtracting them out from each other so that you isolate just the pigment spectra without any of the background. And I won't go into the math here because it can get pretty complicated, but this is just kind of showing the process of going from that first spectra down to the one that we want to look at. So here's an example of what some scissor spectra looks like. So if you think back to FT Raman, this again has a lot more sensitive, has a lot more peaks information from it. So on the top, we have the purple dye again. And on the bottom, we have a Bible and a map, so some pigments from there. And from this, it does look like that both of them did have, in fact, the purple orison pigment. So why do we want to use SIRS or scissors over FT Raman? Well, there's a couple reasons. So one of the downfalls of FT Raman is you need a very concentrated sample to get basically to get enough data that's usable, to get a high enough peak to be able to tell what you're looking at. And SIRS is preferable over FT Raman for that reason, because SIRS is so sensitive that you can basically use molecules of a pigment to get the same data that you would get from FT Raman using a very very concentrated sample. So that's why SIRS is only considered an invasive technique and not a destructive technique, because you need so little of a sample to get that data. And then scissors is preferable over FT-Raman because the way scissors works. So when you take a spectra of a manuscript, so scissors, you can literally just put the manuscript right in the Raman. You don't have to take any pigment off. And because you just put that right in the Raman, biological things can give off a lot of fluorescence, and the parchment, which is made of animal skin, will have a lot of fluorescent signal coming off of it. So scissors basically will isolate the pigment and get rid of all of that background fluorescence, which FT-Raman does not do. So scissors can give you a more accurate reading on that pigment without any of that background. And then scissors is also a little preferable over SIRS because scissors is both non-destructive and non-invasive, where SIRS is invasive. But one of the benefits of scissors is that you can get the same data from different samples. So for example, if you're using SIRS and you're looking at that purple orison again, if you're looking at two different manuscripts that both have the purple orison, and you know it's orison, but then you have to take those samples off and create that metal ion complex. The way the metal ion complex is created, it will differ when you take the spectra. So the spectra is going to differ slightly depending on how the metal ion complex is created. But with scissors, you can take, if you know you have orison again in two different samples, if you take the spectra, you can get the same exact data, proving that it's the same orison from both samples. So scissors is preferable because it has, because it can be used for things like creating a database. So if you have a pigment and you don't know what it is, then a database or something similar could be created with scissors for you to compare your spectra, where with SIRS, this isn't really possible. So again, let's go back to one of the first manuscripts that I showed. So what can this tell us? So we know we have multiple colors here, and that can tell us that the owner was probably a little wealthier. They had some money, and if that bluish color, if that was more of a purple, then depending on if that was the royal purple or the orison, you would be able to tell even more about the wealth of the owner. And then, for example, if we knew that this was sheepskin, then again, you would be able to infer that it was probably from the UK based on that map that I showed earlier. So really, there's a lot of different things that you can figure out between the parchment and the color information you get. And then to finish off, I want to talk a little bit about the challenges with this type of research and analysis. So a lot of the people that are interested in this research are places like museums and private collectors and stuff like that. And the problem really comes with money a lot. There's not always a lot of money and opportunity for research like this. So the instruments that I talked about, the Raman and the MALDI-TOF, those are very expensive instruments, and they're not things that places like museums really have access to a lot. So that can be challenging, especially when we're talking about art conservation, where information like this, like certain pigments should be treated certain ways, like stored properly, and making sure you're storing the parchment properly. So museums could really use this information, but it's a lot of times difficult for them to get it because there's not really money for this type of analysis. But one upside to the parchment analysis with the eraser method I talked about. One of the studies I looked at, they sent a bunch of erasers and little kits out to libraries and museums, and that type of analysis, they were able to collect their own little eraser fragments themselves and send it back to the lab to get analyzed. So there are some benefits to some of the methods that have been figured out for analysis like this. So like the MALDI-TOF is more accessible than say the Raman is. So I'd like to acknowledge Allison especially for helping me out through this whole thing. Like she said, we've had a lot of ups and downs with this, a lot of changes. The rest of the chemistry faculty for supporting me these 4 years. Erin, Cho, and Jojo, who helped me put together this presentation a lot. All of my chemistry classmates, and my friends and family for supporting me throughout this process. And if anybody has any questions, I would be happy to answer them.
Yay. Good work, Lindsay. I think she would be happy to entertain questions from the audience at this point. Jojo.
Yeah, so you said that there is a way that people could convert new parchment to be chemically like old parchment. I was wondering if you know any idea of how they do that, because that just sounds really interesting.
Yeah, so like the yellowing, let me go back to that slide. So like you can tell like one of the big differences is like the yellow color. And I did look into that. One of the reasons why it's so much yellower is it's basically like collagen degradation. So the collagen degrades and they can basically force the collagen to degrade, which is what ages it.
Cool.
Lindsay, I have a question for you. Also, great job on your talk. My question is, would you expect to see any fluorescence coming out of the dyes in these parchments?
Not really. It's usually more biological stuff that causes fluorescence. So a lot of the like dyes are like inorganic compounds and stuff like that. So we wouldn't really expect to see fluorescence coming from the dyes themselves.
I have a question for you. I love the idea of like mailing erasers out to museums and like having them send samples back. That's such a like efficient process. Has that ever been done before with other like kinds of art or like other museum items that the like museum staff, because I assume museum staff are like highly trained in art preservation. Have they been recruited for other types of research for collecting samples for different labs?
I don't know, but that would be very interesting to look into.
Other questions for Lindsay? All right, well, if the audience is happy, we can thank Lindsay again for her talk today. And this officially marks the end of the 2021 Senior Seminar Series. You've made it. Seniors have completed the last checkbox for their talk. Congrats to Lindsay and to the other seniors.